Sorry, were you done with the intro there just before I carry on?
Yeah, go ahead.
Excellent, cool. So hi everyone. So today I want to talk to you about Playwright and why I'm really excited about Playwright, and I hope I can sort of rub some of that off onto you in this talk. So I'll be doing just a few slides and then going into some code demos. So I'm hoping that the demo gods will be kind to me today. So just a quick intro on Playwright and what it is. So in a nutshell, Playwright enables reliable end-to-end testing for modern web applications. So it sort of started as a web automation library, and it's sort of grown more into being a really nice fit for just general end-to-end web application testing for modern web apps. Now, when you think about sort of web application test frameworks, you'll probably think of some of these sort of usual suspects. I know in Legacy Just Eat, we use all of these, and now we're using Playwright as well, so that's like at least 5 in the mix. And they're all really good, to be honest, and they all have different use cases and different strengths and weaknesses. But there is definitely room for a new one, in my opinion, and I hope I can persuade you that as well. So what makes Playwright different? What makes it stand out? Well, let's start with the basics. For me, these are kind of things that I come to expect, but it's good just to spell them out. Playwright is cross-browser by default, so it works with anything that is based on Chromium, WebKit, or Firefox, which is all sort of modern web browsers. It's cross-platform as well, so you can develop on any of the Apple, Linux, or Windows. As well, they have official Docker containers and instructions on how to set it up with the CI/CD. And it's also cross-language. So by default, it's an open source library that's built in JavaScript. It's a node package. And that's where all the features come first. But then they also have official language bindings for some of the major languages out there, like Python, Java, and .NET. And I'm going to be showing the .NET one today because it's what I'm most familiar with. But whatever I show today is applicable to all these other languages because it's sort of a unified API. And it's, in my opinion, a bit better than the sort of situation with Selenium. With Selenium, it feels a bit like a one-size-fits-all API, whereas with Playwright, like the Python version feels like idiomatic Python, and the .NET one, when you're writing it C#, it feels like you're writing idiomatic C# code. So it feels really nice to use. Another sort of really good strength it has is sort of resilience. And you get fewer flaky tests. I say here no flaky tests. That's probably a lie because when you're doing end-to-end testing, you do just have a general level of flakiness, but you tend to get less with the sort of web browser interactions. And Playwright has some smarts in it to make that less likely to occur. One of those features is something called auto-weighting. So by default, whenever you try and interact with a page and you try and sort of, let's say, in this example, click a button. And this table I've taken from the docs, by the way, I've just sort of trimmed it down to a few. There's actually like 20 lines in it. But let's say you try and click a button. There's a whole bunch of stuff that Playwright does for you automatically. Like it will check that the DOM element is attached, and it will check that it's visible, that it's stable, it's not like moving around, it's not, and it checks that it's scrolled into view, that it's receiving events, and a whole bunch of other stuff before it tries to actually click it. And that's really important because, like, let's say you have a React application, you don't want to try and click a button because technically it was enabled, but there was no event handler hooked up yet by React. So definitely for modern web applications, you kind of want this stuff baked in. You don't have to kind of write it all yourself. So you kind of just get that for free. And it's not black magic. You'll see later on, we can actually see these weights in action and when they happen, and it's well documented as well. Another reason why it's so resilient is, and this is a bit of an implementation detail, is that it uses something called the Web DevTools protocol. So browser web dev tools are super powerful. I'm sure those of us who build web apps know that, like, they're just phenomenally powerful. They're sort of really essential to developing a web application. And the way that Playwright works with your browser, rather than using WebDriver and like separate mechanisms to sort of work with the browser, it will talk straight to the web dev tools using the Web Dev Tools protocol, which is a standard that was sort of pushed by Google, and they're supported by all major browsers. And this is amazing because the web dev tools can see right into what's going on in your page. They can see like the network stack and all the web requests. They can see they can do things like shadow DOM piercing selectors, which I don't fully understand, but I know that something like it isn't easy in other frameworks, and this is just something that, because it's using web dev tools, you just get for free. And this is part of what makes everything so resilient in Playwright. So I really like that. Something else you get is isolation and fast test execution. So when you're working with Playwright, it has this concept of contexts. So when you're using the APIs, you can spin a browser up and you can start working with web pages. But it has this concept of contexts, which are a little bit like incognito sessions. You can think of them. They're sort of ways of creating isolated sessions that can have pages within them that don't share any state. They don't share cookies. They don't share local storage. And what's really nice about them is they're really fast to create. They take just a few milliseconds to create. So you sort of typically create the browser once and then create lots of contexts, like a context per test, and they have full isolation. And because they're so cheap to create, you get fast test execution. So really nice. And finally, for me, I find the tooling around it to be really impressive. And I'm going to show that. Hopefully, you're going to see that come through in the demo that I'm going to do. Yes, now, good. So if I switch over from my slides to some code, here is, and apologies if you're following along, you're not a C# or .NET developer. What I show you is going to be generally applicable to whatever language you want to develop in. So here's just an empty console application where I'm just writing hi to the console. And all I've done is, if we look at the project file, is I pulled in the NuGet package for Playwright. And with that, we can start programming. Oh, not a very helpful GitHub Copilot suggestion there. We can start coding against Playwright, but a really nice way of getting started is to use some of the tooling that I talked about that's really nice. So let me switch over to my desktop. Oh, apologies. And here's my console. I hope you can see the font size here. Apologies, it may be a bit small, but I'm in my project file here, in my project folder, and I can, inside of my bin folder, there is this sort of bootstrapping script where I can perform various actions. And one of the things I'm going to do is just ask it to do some code generation for me. So if I run that, then hopefully, yes, you're not going to see it because I've got two monitors here. So let me just drag it across. But it popped up a web browser and a separate inspector window here. So let me just browse to Google for a second. And I'm going to accept the terms and conditions. I'm going to search for Just Eat and go to the Just Eat webpage. And I'm going to accept cookies. And that's all I'm going to do for now. I'm just going to click the copy button in the Playwright inspector. And look here, it's written all of the code that I would want to write. And I can change this, of course, if I wanted to target Python or the other languages that it supports. I'm going to stick with C#. Let me close this. Let me go back to my code window and paste that in. And I'm going to just tidy this up a little bit, just because I like things tidy. And we have some code. I'm just going to run it. And unfortunately, I think it's going to spin up on my other screen. And by the time I grab it, you're not going to see it. Let me see if I can grab it in time. Right, I've grabbed it. I've missed it. Yeah, and I think it's finished. Yeah, don't worry. I will actually show it properly in a second. But when you generate the code, it will automatically create it with this headless false. So actually, I was seeing the browser there doing its stuff. You can also add like a slow-mo to slow it down so you can see what's happening. But if you take this away, by default, it's going to be headless, which is what you want in your CI/CD scenario. So to talk through the code here, I'm hoping the code size is okay here. If it's too small, just give me a shout and I can increase the font size. But what we do is we start up Playwright with this top line here. And then it supports a number of browsers. It has like Firefox, WebKit, or Chromium. And we're using Chromium here. It's going to start it. And then this is what I was talking about before. This is the idea of a context. And a context has that sort of isolated state. And now we can, like, if we were just writing a quick test, we could just say browser.create, no, not create, sorry, new page, and just create a page. And implicitly there'll be a context there. But it's when you have a large test suite, it's nice to be explicit and have this context where you can create multiple of them and have complete isolation. We then create a page, and a page is what you use to interact with stuff. So you see here, we can go to an address, and then off of the page, we've got tons of things like, we can click on things and, browse the things and interact with anything on the page. This is kind of the main API that you'll be interacting with Playwright. And just to sort of complete the walkthrough of the code here, Playwright has this concept of selectors. So if I want to click a button on a page, the first thing I want to do is get the button. So you'd call locator, and then you'd pass in a sort of selector. So it supports CSS selectors out of the box, but it also has other selectors. You can use ID selectors, but it has an extensible selector engine. So you can plug in it also has a React selector and a Vue.js selector as well. And you can plug others in there. It also, these selectors themselves can have like nested. So you get back a locator. You can do a locator within a locator. So very powerful API. You can think of the locator you get back from the page a little bit like an element, but it's not quite a DOM element. You can get the DOM element. You can say like element handle, but you can think of the locator as a live selector on the page. So let's say something changed on the page, the locator would go and find it again, basically. And that's primarily how you interact with stuff. And it's also created a bunch of comments for us we probably don't need here. So, it's going to wait for page to navigate, and it's also generated a bunch of asserts we don't need. But it's a really nice way of getting started. But what about after you've created your starting point and you want to kind of develop it? There's a really handy tool it has. Let me take a code snippet here. A really handy tool it has where you can enable debugging. So here, when I have a debugger attached, I'm going to set an environment variable called Playwright debug. And if I run this now, what's going to happen is anytime Playwright gets to the point where it's going to do some interaction with the page, it's going to pause. And that's really handy now because I can actually drag the browser across and show you it. So here's the browser. And then here's the inspector. So you can see here that it's paused it on my code. I can see my C# code. I can see what it's done so far in the log. And I can then say, yeah, go to the next step. And it will pause again. I can see what it's done in the log here. I can see that it's waited. And then I can actually say explore, and I can start to look at some of the elements in the page. I can click on it, and I get the selector for that. So I can copy that, and I can start to update my tests. And obviously, I can use the web tools here as well. So this is a really nice way of kind of interactively developing it once you've got it, once you've made a start on it. Oh, you see, you also get any C# errors. I've left the timeout to 30 seconds, so you can see that's now reported here as well. So that's super useful. You can also continue recording from there if you've got extra things you want to record. You can pause at a certain point, hit the record, and start to have it generate more code for you. So that's super handy. But what about when you actually have this running on a CI server where you don't have that kind of ability to inspect it interactively? What do you have at your disposal? And with other frameworks, you have things like logging, you have screenshots, and you have videos. But in my opinion, videos aren't very helpful, especially when you have like a headless browser and it's flying along at like, let's say your test takes 5 seconds to hit a bunch of pages. When you watch the video back, what are you going to get from that? You're going to see roughly where it fails, but you're not going to know what happened, right? So for me, video recording isn't very impressive. That said, you can do all that actually. You can record videos with Playwright. You can even record HAR files, which are like network traces, so you can replay them. You can open that with Fiddler and replay requests. Super handy. But it has this nice feature out of the box called traces or tracing. And let me grab some code to show you what that looks like. So after we create a context, we can add a bit of information and start a trace. I'm going to give the trace a title. I'm going to enable screenshots, snapshots, and sources. I'm going to show what that is in a minute. And when my test finishes, I'm going to save the trace to this trace.zip location, this file. So let me run that. And it's going to be running this on my other screen again, so apologies, not going to see it. And it's just doing that now. And if I head back to my desktop and I open my bin folder, you can see here it's just saved a new file, a new trace file. So this is 3.8 megabytes, and I can talk in a minute about what a lot of that is. But this is actually relatively small. Like if you compare it to like videos and other things, this is quite a small file for what you get inside of it. So let me show you what you get. So another command you can run is this trace viewer. You can show the trace. And let me show you what that looks like. So this for me is super cool. This is where Playwright is like above and beyond the other tooling out there. You get this thing called a trace viewer. So this is the local view of it. And I'm going to talk about in a second what all this is. But what's even cooler is like you don't have to use the local trace viewer that ships with Playwright. You can actually use the online version. So if I open a browser, you can go to trace.playwright.dev and you can open the file here, which is pretty cool. But even cooler than that is you can give it in the URL a reference to a file, maybe on your CI box, and then you can open it straight in the browser without having anything installed. So here's a bit of audience participation now. I want you to browse to stu.dev, which is my blog, shameless plug, /pw for Playwright. So if you browse to stu.dev/pw in a new tab, I won't be offended, go off, do it right now, and hit enter. I hope it's still there and it's still hosted correctly. You should see this redirects you to playwright.dev. What's really cool about it is it's a portable web app. So although it's in the browser, we're not passing any files to Playwright. This is all done within your browser. Nothing leaves your machine. But this file is fine. It's completely, this is on my public AWS S3 bucket. So there's no secrets in here. In fact, this test here, this trace I'm showing you, Martin's on the call here. Martin may be familiar with this. This is his open source tests that he has available. And I've just taken his code, switched tracing on. So you can, if you don't like this test, you can blame him. But here's one, you can sort of see what it does. So just to explain what you get in this trace viewer, you get a timeline view here, which we can mouse over and scrub. And yes, it's a bit low resolution. If you look at the image here, it's not the highest quality, but like you can see everything load in. You can see animations, like if you've got modals that fade in, you see it like in relatively high detail. And that's all contained in the zip trace file. So like this is much better than video already, right? In my opinion, because you've got then the context we can click and we're taken to the actions on the left. So this is everything that Playwright did on the left. And this is crazy. I'm just gonna like freak out trying to explain everything here, but let's start with the click for the I agree page on Google. On the right hand side, you get the log of everything it's tries to do. So remember I showed you all the auto weighting stuff. This is what I'm saying when I say it's not black magic. You can see here we've attempted, we have waited for the element to be visible and enabled. We've waited for it to scroll into view. We then perform the click action. And then if we look in the main view here, this is, again, crazy. You get the entire DOM saved in the trace file. So if I right click here, well, if I mouse over the buttons, do you see them hover and interact with the CSS? Like, this is the page embedded in the trace. This is crazy, right? Obviously JavaScript won't work because it's basically like you've saved the page DOM statically. But like, you can actually right click, open up an inspector, and use web dev tools to see the state of the DOM. And what's cool is this is, if we click on before, this is the DOM before it even started in this log. We can click after and see that it's gone because the navigation finished and then it took a snapshot of the DOM. So you got it after. And then the action tab is when, just before it performed the action here, before it performed the click, it also took a snapshot of the DOM. And you see here it's highlighted the button it's tried to press. So like, you get, this is crazy in my opinion. This is mad. And then even more, right? Let's keep going. You get the console tab. The console tab shows you anything that came in the browser console that might be relevant. And then you have the network tab, which shows you any web request that happened. So if we look here at some of these, these are boring. I'll come to one later. But you see all the web requests, all the headers. Let me come to this one at the end. Yeah, so Google on their web page results have like a log, a Google Play log thing. We can see the full body in the post request, the full JSON body, and the full JSON response, right? That's crazy. Super cool. And then finally, we actually enabled embedded sources. So when you click on the source tab, you can also see our source code. So if I click on search text here, you can see the code that Martin wrote that I stole, and the highlighted line to show where it is. So like, we can just trace it right back to the source code and see what happened. And if I click through here, and I want to show you, in our team, we've used this heavily. And I want to give a shout out to John Button, who's on the call. He's the QA in the invoicing team. And he's done a lot of the work to rewrite our Selenium tests using Playwright. And so we use it quite heavily. And just to show you what it looks like when you actually have some real code, if I click on one of these options here and view the source code, let me reload the page. It's playing up for me. Okay, I'll use this one instead. Oh, demo fail. I should have. We try again. Yeah, we can click on the source code here. You also get the call stack, so you don't just get the code, but you have all the call stack that led up to that code. And we even have, like, we're using SpecFlow, which you may or may not be using, but we even have like the Gherkin line of code from the SpecFlow, like from the Gherkin file as well. So it's crazy the amount of information you have here to kind of work with. And so what we've done on our team is we've switched this on for our CI servers, regardless of whether they pass or fail. So we record a trace file for every test. And then we present them. I built a crude little dashboard where, and John in our team switched on this living doc, which is a SpecFlow feature. So if I show this quickly, in our test here, you see the Gherkin text. And if you actually select a scenario and pick an example, you have to click a bunch of things. Here we go. What we do for each test is we print out the URL for the trace log. So you can click it and go straight into, from your test output to the Playwright test without having anything installed locally. And what I did to make that easier for us is in this dashboard, I actually just scrape that same payload that drives that page. And I have the little Playwright icon. So I can click on any of my tests, like this one here. It takes me to Playwright. This doesn't leave our network. And I can see everything that happened. And what's amazing is when the tests fail, if they fail, we get a full trace. We can see, oh, this network thing failed. You can do things like you can add headers for traceability. what we've done in this as well, if I have an example ready, here's an example where it failed. We can see the console errors. We can see on the next line, actually, if we come back here, we see why it failed, because the network request failed. We had a 500. And then on the last line, we also print out a console link to Kibana. So we can go straight to Kibana, filters for this application for that timestamp. And unfortunately, this was a month ago, so the logs are gone. But we actually would get the error that caused this test to fail straight from the downstream API that caused it. So this has helped us hugely. And I know that in porting it over, it's made it a lot easier. And I know that it's probably made John's life easier porting it across as well.
Yep.
Thanks for the confirmation, John. Cool. Okay, back to the slides. There's probably more code I could show you, but I realize I'm pressed for time. There's other things you can do that are crazy because it has integration with the browser. You can do things like intercepting the web requests and actually mocking the response out, so you don't actually hit your web server. And this is really nice for like test failure scenarios, like when you want to have a timeout happen that's hard to simulate or slow to simulate through actual faking out a web server. And you can actually do it in the network stack. So things like that, you have better capabilities and features inside of Playwright. Oh yeah, that's the link if you want to go play with that trace, stu.dev/pw. So just have it all play. Hopefully that sells you on it. I'll share these slides after. Here's some awesome resources. Playwright.dev. It's not just a good set of docs, it's actually a bit more of a walkthrough as well as a set of docs. You can also switch the language that you're looking at in the top menu bar, and it switches all the examples out for your language, so it's really nice. Martin, a shout out to Martin. I've got an example here of his test that I used. He's also done work to integrate this with Browser Stack and make it work well with Browser Stack. And I've gone a little bit over on what I thought I would, but I hope there's still time for some questions. If so, feel free to unmute yourself and ask a question, or just put it in the text chat, and I'll read the question out. There's got to be a question.
Yeah, not everyone at the same time. Yeah, there it is.
Okay, I used Jest with Playwright and didn't know this other feature existed. Thank you. Okay, cool. Good. Glad you found it useful. Cool. Yeah. Sorry, I realized gone past the half past, but yeah. All right.
Thank you, Stu.
Just one question.
Yeah, sorry.
Yeah. Sorry about. I know it's late. So Stuart, one quick question. Would you recommend this for API testing, just for the API testing, because I know it's more on the web UI side?
I wouldn't personally use it for API testing. That said, if you've got a web application where you do need to do some web API calls, it actually has some functionality where you can do API calls through the browser, which can be handy. Let's say like your browser has some like authenticated state and you want to use that in your web request.
All right.
You can kind of make API calls through your browser, but programmed in Playwright. But if all you're doing is API testing, I personally wouldn't use this, even though you get the things like the tracing and all the rest of it. That's kind of cool. So yeah, that's my take.
All right. Thank you.
Cool. All right. Happy to take questions offline. So yeah, thank you everybody for attending. I'll hand back to Lee.
Yes, thank you, Stu. This was great, and so thank you for sharing. Thank you everyone for joining. I'll also be sharing the recording and the presentation if Stu allows, which he already said he does. And yeah, happy hacking. Enjoy.
Yeah, have a good hackathon, everyone.
I did not know you can add emojis to the chat.
Oh yeah, it's essential. Thanks, everyone.